Fourth grade lesson 7.1 is add and subtract parts of a whole. And as we're going into chapter 7, we're going to be learning how to add and subtract fractions and calculate with fractions. But as you know, GoMath is preparing us by starting us off little bit by little bit, one bite at a time, so that our brains can put it all together and make sense of it. So let's get started. Lesson 7.1. Okay, our essential question is, when can you add or subtract parts of a whole? Investigation materials are fraction circles. I do have some in the classroom, so if you need those in front of you, you can use them. If the pictures are enough, that's fine too. It's up to you. Colored pencils, you guys have some crayons you could use. Miss Clark has the following pie pieces left over from the bake sale. So she's got this much here and this much here. And she wants to combine the pieces so they are on the same dish. How much pie will be on the dish? So they tell us we can model the problem using fraction circles. We'll draw a picture of our model and then write the sum. So we'll start with this one here. We're going to shade in the 1, 2, 3 pieces. See, it was cut into 6 equal pieces. If we had extended this out, I'll even extend this up here so you can see it. Okay, there it is extended out. The lines are cut. I guess I should have put one right here too, because that was a cut line too. Making a total of 6 pieces as this shows. And out of the 6 pieces, 3 of them are still there, and that's what I'm going to shade in. 3 out of 6, 3 out of 6. Let's look at the other one that had some left. If you do those cut pieces, you can see that was the same size as that. So it's 6 pieces that were there originally, but only 1 is left. So here, out of the 6 that were there originally, 1 was left. So I'm going to shade that. And that is 1 out of the 6 that were there originally. So if I take this piece and put it over here, I'm just going to go ahead and reshade this on my sum over here. Shade those 3. And now I'm going to take this one piece and just put it right over here because that's where it fits. So right here, I'll make it a different color just so you could see. There we go. So this 3 is here, this 1 is here, and now that I have put them together on the same plate, I have 1, 2, 3, 4 out of the 6 on the pan. So there is 4/6 of a pie is on the dish. 4/6 of the pie is on the dish. Now let's suppose that Miss Clark eats 2 pieces of that pie. How much pie will be left on the dish? We're going to model the problem using fraction circles. We'll draw a picture of the model and then write the difference. So here we are starting with 1, 2, 3, 4 out of the 6. So we start with the fraction 4 out of 6. And what we're taking off is the 2 pieces that she ate. I don't know why she ate so much, but whatever. So we're going to take those, and I'm just going to put an X over them, saying that I'm taking 2 out of the 6 off of there. And they're gone. So off they go. They're gone. And what does that leave me with? It leaves me with just these 2 out of 6. There is 2 out of 6 of the pie pieces left on the dish. So Kevin says that when you combine 3 pieces of pie and 1 piece of pie, you have 4 pieces of pie. Explain how Kevin's statement is related to the equation 3/6 plus 1/6 equals 4/6. So back to that picture we had, where we had 3 out of the 6 pieces, added 1 out of the 6 pieces, and we got 4 out of the 6 pieces. So how is Kevin's statement related to the equation? 3/6 shows the amount here, 1/6 shows the amount here, and 4/6 is the amount that's totaled when you put the 3 and the 1 together, provided that all of those pieces were cut into the same amount. And so that's something we'll get to later. In this example, they were cut, this pie was cut into 6 equal pieces, and so was this one. If they were cut differently, then we have other magic we have to do. We'll learn that later. But this statement is true as long as they are cut into the same size pieces, and this equation is telling us that it is. It's cut into 6 pieces here, it's cut into 6 pieces here, and then we can add our numerators. So the way I answer this, I'm not sure if this is what they were looking for entirely, but as long as both pies are cut into 6 pieces, and that's what the equation says there, so I am trusting them, then when you add 3 plus 1, the amount of pieces that are sitting there, of those pieces, you will get 4 out of 6 pieces still there. Let's look at this question. Isabel wrote the equation 1/2 plus 1/6 equals 4/6. And before we go on, I'm going to look at this. You have a 2 plus a 6, and our brains want to say that's 8, but it's not. She's actually correct. 1/2 plus 1/6 does equal 4/6. So that may seem confusing and wrong. Oh, and 1 plus 1 obviously is not 4. So what are we missing in this? Even though I'll tell you now that that is correct, what are we missing and not understanding here that makes this correct when Jonah wrote 3/6 plus 1/6 equals 4/6, and he's also correct to represent combining the pie pieces? Explain why both equations are correct. Well, we know that this one's correct. We've seen it a couple times already. 3 out of the 6 plus 1 out of the 6 put together is 4 out of the 6, right? So we understand why Jonah's correct. How is Isabel correct? Take a look at this 3/6 over here. If I simplified that fraction, I have 1 out of 2 pieces, right? This amount, oops, drawing, here we go. This amount is the same, 1 out of 2 pieces, is the same as this. These are equivalent fractions. So she just simplified her fraction, but she kept in mind that's 3 out of 6. And when she adds them together, it's going to be 4/6. So she ended up with the same answer. Is that the way you would normally add it? Would you simplify if they had same denominators already? No, you're not going to do that. Your goal when you have to add them is to always get them to have the same denominator first and then add it together. And then simplify afterwards, not simplify before. But technically, is she correct? Yes, because this is technically 1/2. So for my answer there, I just put down that 1/2 that she put here is equivalent to 3/6. Same amount, cut differently, but still the same amount is sitting there. If there is 4/6 of a pie on a plate, what part of the pie is missing from the plate? Okay, we have 4/6. I'll redraw it over here so we can see it. You can draw it on your page right under here. So here I have 4/6 shaded in. That's how much we have. So how much is missing? Oh, well, it's just the rest of it, right? The rest of the 6. It's 1, 2 out of the 6ths that are missing. Simplified 1/3, right? 2 out of the 6 are missing or are eaten. Somebody ate them all out. And I can check that answer, by the way, is if I have 4/6 there and 2/6 are gone, when you add those together, what was there originally should be one whole pie, 6 out of 6, 6 pieces out of the 6 that were there. So that's something you can check your answer on. But 4/6, if they ask me how many pieces are there, I would say 4 out of 6. If they ask me how many are gone, I would say 2 out of 6. So let's look at this next part in Make Connections. You can only join or separate parts that refer to the same whole. I'm going to underline that. That's super important to understand. So here's where it explains it better. Suppose Randy has 1/4 of a round cake, 1 out of 4 pieces of a round cake, and 1/4 of a square cake, 1 piece out of 4 cut pieces of a square cake. Are the wholes the same? Well, I could see that this shape is different than this one, and if I even overlapped them like that, I overlapped this piece onto this, you could see that they don't equal the same amount. They're not the same size piece. So I can't put them together over here and say, oh, looky there, I have 2/4 of a pie or half of a pie or cake or whatever. No, not really, I don't, right? It's not exactly 1/2. So if we're looking to be exact on our amounts, we need to recognize that I cannot compare 1/4 with 1/4 if they're not the same size and shape. If they're not the same size and shape, I can't just put them together. those are different fractions. They're representing different amounts. So on that, I'd probably put something like, no, they're different shapes or different amounts, something like that here. They're not the same value. This 1/4 is not exactly the same amount as this 1/4. They're different. So does the sum 1/4 plus 1/4 equal 2/4 make sense in this situation? No, because this isn't 2 out of the 4 pieces. This isn't even the same shape or size. This isn't 2 out of the 4 pieces. These are not the same shape or size. So I'm going to say, no, that doesn't make sense because they are not the same shape or size. No, because they are not the same shape or size. So that's important for us to recognize when we're comparing fractions that are cut up the same way. Yes, we want them cut up the same way, but they need to be the same shape and size item, the same shape and size pie or cake or whatever we're cutting up. They need to be the same shape and size, cut up the same way in order to do it. If they're cut up the same way, but they're the different shape and size, you are not going to get an accurate answer. So that's something to put in the brain there. All right, so for the share and show, they want us to use the model to write the equation. So same size, same shape, same size, same shape. So I can put those together. I'm having trouble saying that. So I'm going to start with how much this is. This is 1, 2, 3 out of 1, 2, 3, 4, 5 total pieces. So I'm going to write 3 out of 5, 3/5. And it's being added to 1 piece out of 1, 2, 3, 4, 5 pieces. 1 out of 5 pieces. And when I put those all together, 1, 2, 3, and 4, 1, 2, 3, and 4, there's 4 out of the 5 pieces. 3 plus 1 is 4 out of the 5 pieces. I'd like for you to notice that my denominator didn't change. I didn't change how many pieces I cut that into. I simply changed how many pieces were there. I took one off this plate and put it on this plate. So make note of that. My denominator didn't change. That denominator is how many pieces it's cut into. Okay, let's take a look at number 2. I was super confused by this at first. They mean we're cutting this piece off. That's what this symbol means. All right, so I have 1, 2, 3 pieces here. And out of the 3, before this little symbol shows up, I have 2 of them shaded. And now I'm going to cut off. That's what they mean by that. I was super confused for a while. Cut off one of those pieces, 1 out of that 3. Well, cut off, as you know, is subtract. Let's do the right color. 1 out of the 3 is going to get cut off of there. And when I cut off one of the 3, or take it away, I'm only going to have 2 minus 1 is 1, this 1 left out of the 3 that were originally there. Notice again, so when I add, my denominator didn't change. When I subtract, my denominator doesn't change either, because I'm not changing how much it was originally cut into. I'm just changing how much of those pieces are there. Let's look at number 3. You can pause this one and try this one without me and see how you do, because you're probably feeling like you've kind of got this now. I'm double checking for same size, same shape, and they are. This is 1 out of 1, 2, 3, 4. 1 out of 4 being added to 1 out of 1, 2, 3, 4, 1/4. And when I add those together, I end up with 2, this one and this one put together, 2 out of the 1, 2, 3, 4, 2 out of the 4. And as you know, because you know how to reduce fractions, if I divide by 2 and divide by 2, I'd end up with 1/2. And when you look at the image or the picture or the model, you could see that's 1 out of 1, 2 pieces, 1/2. It's just cut into 4 in this circumstance. Okay, how'd you do? I hope you got that one correct, or you understand what you did there. Okay, now that we know what this symbol is representing, go ahead and pause the video and try to do the equation for this one. This 1 bar is only to show you that there's all 8 of these pieces there. So you're really only referencing these 8 pieces. Go ahead. All right, let's see how you did. I have, starting with 1, 2, 3, 4, 5 out of the 8 equal pieces. So I'm starting with 5/8. And then we're taking off, that's what this symbol means, 1, 2, 3 out of the 8s. And after I did that, how much was I left with? I was left with 2 out of the 8ths, reduced would be 1/4. But anyways, they didn't ask for us to reduce it. 2 out of the 8th are what's left. So 5/8 minus 3/8 equals 2/8. Notice denominator stayed the same. It's how many pieces that's cut into. We're not changing the cutting. We're just changing how many pieces are there. Hopefully you did well on that. Or if not, that's okay, as long as you caught where your error was. Let's have a look at this one. 3/4 minus 1/4. They went ahead and modeled it for us. This is one whole, and that would take 4 out of the 4s to make one whole. They start with 1, 2, 3/4. They take 1/4 off, and that's going to leave us with 2 out of the 4. 2/4, also known as 1/2. 3 minus 1 is 2, and we didn't change the way we cut it, so our denominator stays the same. Let's look at this one. You can try it first and then push play when you're ready. We have pi cut into 6 equal pieces, so my denominator is 6, and I have 1, 2, 3, 4, 5 of those pieces, 5, 6, plus 1, 6, 1 out of the 6 pieces. 5 plus 1 is 6 out of the 6 pieces, and if you add 1, 2, 3, 4, 5, 6, you get the whole thing. It fills in all the pieces. This one piece just stuck itself in there for 6 out of 6, which also is the same as one whole, right? The whole thing. I also want to look at number 7 with you, just to make sure you're understanding this. There was the make connections was explaining this, but this just lets us kind of delve into it a little more to let our brains understand it. Sean has 1/5 of a cupcake and 1/5 of a large cake. First question, are the wholes the same? Well, a cupcake is not the same as a large cake. A cupcake is small, right? And a cake is much bigger. That's a cake with a candle on top. A cake is much bigger. 1/5, 1 out of 5 equal pieces on this cupcake is going to be much smaller than 1/5 out of this cake. So the holes are not the same. One is much larger than the other. So I've put here, no, one cake is larger than the other. Does the sum 1/5 plus 1/5 equals 2/5 make sense? No, because 1/5 of the little is not the same as 1/5 of the big. And so when I put them together, I'm not getting 2/5 of the little, and I'm not getting 2/5 of the big. I'm getting something entirely different. So no, it does not make sense in this situation because these are different sizes. So my answer is no, the cakes are different sizes. So I wanted to look at that one with you just to make sure in our heads we know anytime we're adding fractions, we have to have the same size, same shape sort of item that we're adding together so they fit together the way they're supposed to. I also want to look at this one with you. Carrie's dance class learned 1/5 of a new dance on Monday and 2/5 of the dance on Tuesday. What fraction of the dance is left for the class to learn on Wednesday? Okay, well, I find it easy or helpful for me to draw pictures when I'm still learning something. So I'm going to represent as a rectangle one whole dance. That's going to be my representation of one whole dance. And I can see that they've split the dance into 5 stages, 5 pieces, because that's what the denominator is about. So I'm going to split this. I'll put 4 hash marks. Will give me 5 equal pieces. 1, 2, 3, 4, 5 equal pieces. It is split into 5 equal pieces. And we've learned 1/5 of it on Monday. And then we learned 2/5 of it on Tuesday. So I'm going to shade in what that looks like. 1/5 was learned on Monday. 2/5 was learned on Tuesday. So if they asked me how much was learned, I would say, oh, 3 out of the 5, 3/5 of it has been learned. But that's not what they asked me. So we have to really pay attention to the question we're being asked. What fraction of the dance is left for the class to learn on Wednesday? So if we've learned 3/5 of it, and we need to learn 5/5 of it, I'll be left with 2/5 that I still need to learn. So there it is, calculation-wise. There it is visually. They didn't say you had to do an equation. I did it, but they didn't say I had to do an equation. I just needed to see it. So this picture helped me see, oh, there's 2/5 left that still need to be learned. So an error we might see people make on this question is they're going to put 3/5 here because they're going to see, oh, 1/5, 2/5, I've been adding them 3/5, ta-da. No, that's not what they asked me. If they said how much have we learned, then yes, it would be 3/5. But they didn't ask us that. What fraction of the dance is left for the class to learn? So really pay close attention to questions and make sure you're answering the question they ask out of you. We learned 3/5 of it, or Carrie's class learned 3/5 of it. There was still 2/5 of it left to learn on Wednesday. Hopefully this all made sense to you and you're ready to go on to Think Central. If not, please let me know and we'll go over it in class.